Alright, we're making some tools here. I gotta cut these wheels here. These flanges are all bad in the chrome shop. So I gotta remachine all these. So I'm making this, I got this plate here I'm gonna mount them to. And these are spacer blocks that go underneath the wheel. So a few of them down there I've made. So this is basically what's in the machine now is one of these. Solid steel, nice and heavy. Yep. So I've got a bunch of cut-off welding here as part of an old bridge. So making it flat and even. So, probably takes about 10 minutes to each pass here. So this one was all welded right through here, which I already cleaned out. Takes a while to do all this stuff. Looks like it'll take one more pass to clean this thing. Got a ways to go to get to the end. So this is what we call an all-night project. It'll take all night to do it. See, I got on fast feed for the RPM, so even groove each time I take a pass. Right going through where it was welded and cut. It's a lot harder. So it goes back to regular steel there, it got soft again. Cutter supplies the hard stuff for the wheel. So like the other side of the wheel starting to cut. Yep. There's the back side cut. Shouldn't be cutting that much. Maybe my head's not quite square like it used to be. It's gonna get smoky in here. Oh, it's almost 11 o'clock down there, so it's a short day. I almost read that. Alright, well, we'll be back in another hour or two. I gotta make 2 of these, so it'll be a while. I'll be back later. Make another pass here. We're going 3 times the speed and slightly slower speed, but not much slower. I only cut about 2,000. We're doing a cut on this side. And back cutting too, so head must be fairly straight. It cuts about equal on both sides. And you see how we got a lot smoother finish here. Yeah, that's good. A lot smoother. Still takes forever to make a pass. Got that nice hard spot in the middle that really doesn't sound nice when it hits it. There's a lot of fumes in here too. Spot here pretty soon. Hear it ringing. Oh yeah. See that nice spark come out? That means your cutter ain't happy anymore. Oh yeah, those are good for the cutter. There's only one cutter, so finish might be slightly not as smooth on the other side. Well, we'll see. Oh well, got another 5 or 8 more minutes to go. So we'll be back. All right, we're done with the second plate here on the top part of it. Some gooey. Tore up again right there. Get at it. Tears the metal up here, but it's good over here. Twice it did that. Yeah, we just hit that with a file. It's real smooth on this side twice. Oh well. Anyways, our cutter. It's not happy, but it cuts. Alright, so I got both these two sides done here. One on this block and one on this block here. So now I gotta flip these over and do the other side. But we're done for the night. It's midnight. It's the next day now. So, was it a couple hours to do that? Yeah, only half done. Alright, I gotta flip them over. We'll do the other side tomorrow. Then we can continue on trying to get those wheels done. So, anyway, that's it for the night. Okay, we're getting ready to do this wheel here. So this is my third day of trying to make this work. I'm going to make the brake rotors fit up on there, the sprockets, and everything else has to be able to fit around here. This was a stock mag wheel, it was chromed. The chrome shop didn't chrome a very good job, they didn't mask it off. You got tremendous buildup of chrome, both outside, top, inside a hole. So you got lips and stuff everywhere. You can't put anything together. So your brake rotor here will not fit up on here like that. The bearings don't fit inside because it's got a lip chrome up on the lip up there, right up on that lip. And obviously it's not very flat because it's all built up with chrome right here. Oop, wrong direction. So you get that fixed. So I had this plate made up here. It's on top of my rotor table under there. So this basically, you crank this handle here and it turns. Right now I got my indicator set up here underneath the lip of the flange up here so I can see if the wheel straight. So basically I had 5 thousandths variation from here all the way around over to here, and then it dropped 10 thou right here. So I had to go ahead and pull this down. Actually it went up, not down. So I had to pull this down about 8 thou here to get it so it's even all the way around. So now when you crank your handle right here, the indicator will stay relatively close, which is what we want. See? We're basically within 5 thou all the way around this thing. And this has a heavy chrome build up here, but it still relatively follows the rim. So now I got to put this back over in the center, and I got to, like I said, I got to trim this face here down. I got to trim the OD down, the ID down, and all that to get it squared away. So you can see the big chrome lips all over the place on this thing. Some masking to use, which wasn't very much. So I gotta make it all work. What fun. So we're hundreds of dollars into this deal right now, and like I said, I got 3 days of work this week on making it work. Trying to make it all work too. So it's not a very easy job. And everybody thinks they just put a buffing wheel in and sand it down, or stupid, because it won't be very flat when you're done. And that will pretty much destroy everything. So if you want to do that, go for it. I don't work like that around here. So we need to figure out how we're going to do all this. First thing is get the camera out of my way so I can work. Alright, that ought to be close enough right there. Alright, we got this all squared up. I already centered this, so all I can do is bring it back to 0 on my indicator. about there. Almost. Alright, more than 1/10. So I go ahead and check to see how close it repeated. Hopefully relatively close. That's why this doesn't work. I don't know what's so tight. Can't even see the damn thing. Okay. And it's not even close to being on center, which shouldn't surprise anybody. Digitals don't always repeat accurately. Looks like we're going to be about a thou off. It's off in every direction. That's nice. So something is not repeatable for some reason. Not sure what that is, but it's not good, whatever it is. Now you look at a dial that's pretty close. So we moved a bunch though, I don't know why. So I'm going to go ahead and crank this around and see if the indicator moves any. Get over here, you can see it. So I just moved 3 thou. 5 thou movement now. So something is not exactly square, which is not very good. Wonderful. So that's about an hour, 2-hour job to change this all out and double check everything. Or I cheat. I'm all for cheating. But I can't cheat different concentrics. Alright, so we're off a little bit. Alright, that's going to be fun. So, what are we going to do? Good question. Yeah, something's definitely off. That's way off too. Well, something ain't right and I don't like it, so redo it. That's all I can do. So I gotta pull this whole plate up, recheck the center of the rotary table, Check to see if it rotates on center, and then redo everything. Nice. These two bolts have to be pulled out. The other ones I don't have to pull out. Okay. It's one big nut down the center I gotta take out. Which is this size right here. So I'll give me a socket for doing that. Then an extension, and a ratchet. Damn it. If your tools aren't put back, you got to spend twice as long looking for everything. Every tool's in a different location, so they weren't put away. Okay, so we got a socket, 7/8, pulls that off. So, how deep is that? Perfect. Be fun to put back in too. Okay, that's loose. So this whole thing should just pick up. This is heavy. Yeah. Oh, jeez. It's heavier than my back's gonna take. So stand on. What the hell is that? Damn stud. Yeah, that's why it wouldn't come out easy. Fucking stud won't come out. Studs out. Okay. You're missing all the fun over here. Thing's heavy. Yeah, it's like picking up a motor. It's over 100 pounds there, I bet. Yeah, gets me warmed up. Summertime again. Okay, that was fun. Okay. Zero. Zero. Here we're zeroed again. Look how close we are. Now we get to measure this hole. See if it's zero. Of course, this is long enough, so I get to crank up for about an hour now. See, I get to work this handle down here. Get my exercise. I didn't have enough exercise already. Should get some more. I don't know, my back hurts already. Okay, now we can see how close we are. We need to find out where the error's at. What moved? Okay. About 8, 9, 9.5, and 8. Looks like we're slightly off, but not much. Damn it. Okay, we got it. 10. Ooh, way off. 9. We set our zero so it's easier to read. Good that way. Oop, too much. Okay, 10, 10, 10, 10. Alright, so you rotate it, stays the same. Okay, so I was only off by 2 3/10 from 3 days ago. That's how far I've been off. 3 on this one, 2 on that one. So, why is the thing changed by 4 thousandths when that piece of crap is up here on top of my table? That's what I don't understand. So now we've got to spin the table and see if this center changes on us. If so, then that explains where the error is at, which means this rotary table is not very accurate. Alright, so I'm going to put that on 10. We're at 150 degree over here. So I'm going to see what this thing does. Let's see what it does. Appears to be pretty consistent. It's not moving. That's a pretty good sign, actually. And we're halfway around, it hasn't moved yet. So I have to work up a sweat. See, I'm over here working my butt off, see? Okay, we're back around to 150, and we're still at 10. Okay. So, we know this table is centered. We're only off by a 2.5 average. So that wasn't our error. So somehow we have an error on that wheel over there by a large amount, a lot more than I want. And that was the easy part. Now I get to put that damn thing back up in here. That's going to be the fun part. Okay. So first thing I'm going to do is we need to change this stud into a bolt. So we need to lock this thing down with another nut to keep it from moving. But this is pushed on a plate, so I have to double nut it from this side. So I have to get a a jam nut, 1/2 inch jam nut to go on here to keep it from moving. And we'll probably need a thin one, otherwise this will be too short to use, which will be the next problem. So if I get a longer stud, we'll take care of that problem too. So if you go to a longer stud here, see, same length, you can put a big long nut on here, it won't matter for the length. Assuming that's a problem, which we don't know. But more than likely we'll probably find out. So I'm going to take this one out. Here's your difference again. Take our washer, our nut, run it all the way down. Take another nut right here and jam them together. So that's about the same overall length. So we still got the same amount here, except now we have this. The next problem is this is going to drop down on us like that, and it'll drop and be a pain in the butt. You just watch. Okay, so I got to jam these together. Brake rotor's in the way. So that just goes, they're tight. Okay, so now we got a bolt. This will try to drop in the hole without losing it. It'll drop down and hopefully I can find a thread in the plate. There's actually a threaded hole down inside my side here, my rotary table, that I put in there for holding stuff like this. See, I made a little bung down there. So this goes down in there like that, holds it in, just like that. And this gap here is what the thickness of this plate is, but it shouldn't be that tall. No, we only got the plate down in there. So I only need the thickness of this plate. We obviously have a lot more distance than the thickness of the plate here, so I don't understand why we had so much material in there. So I must have had that thing threaded way on in there. So we don't need to be this long. So we'll go ahead and put this back to like it was. With a shorter stud. Now that I check it, we don't need it. Maybe I should have checked it the first time. Oh, can't see me. Okay. One more time. Okay. Check my height. We're still good. Okay. So now put all this stuff together. Go over here. Check this. So with a washer, a 1-inch plate, we still got a little bit of material to go through. So it's still going to have a 1/2 inch or so of threading in with this. I think I'd rather have a little bit more than that, so I'm going to go ahead and move this nut up a little bit. Okay, so now I got the nut barely on the end of the hex there. Okay, now we got probably a full inch of thread going down into this thing easily. Double check the height. Okay, we can't go that deep, so that thing bottoms out early. So we can't go that far in. thicker than my one finger, so. Okay, we should be good at that height. Okay, unscrew that. And the washer in there, we should be high enough to do what we need. We'll have good thread in here, and not bottom out and tighten place the table if we want to, so it doesn't move. Hopefully, we'll find out. Okay, now I get to figure out how to get that big ass plate back up onto this mill, which is going to be nice and fun. Yeah. Should be interesting. At least this time I don't have to slide it because I don't have to lift the stud up. But that thing is heavy. That is heavy. Oop, bang bang. See, that's on wheels. We can move it. It's a die cart. Just for making my life easier. Look how much easier it's becoming already. Okay, roll that thing right in there. There we go. I get it that close. Shove it in there. If it'll shove, which it doesn't want to. Not sure why that doesn't want to slide over. Oh, it's got these through bolts. Nope, damn it, too close. These through bolts have a stick underneath here. Not helping my flat part of my table any by doing that. Make sure they're off my table. I'll be chewing that thing up. Okay, we're good on that side. There it is, rubbing across the back side, we're good. It's a lot less effort than the first way. Okay. How are we looking? We are looking pretty good. Right there. Should be close enough. Drop it down a little bit. Cardboard stuck in there. We can live with that. Okay. All right. Yeah, that was a lot less effort on my part. I like that. That's that work smarter, not harder method. I just work harder. That tends to work too. Bring it down that way a little bit. I gotta crank this thing way back down. Remember, I just cranked it way up. Now I get to crank it way down. What fun. We'll run out of room pretty soon. Okay. I've got slots here in the table that match the plate. So if I just kind of line up the slots, the plate should line up. You do that by just putting your fingers in there and feeling and looking. You can see which way you need to go. Okay. What I didn't do, I didn't mark which side of the wheel was the high and the low. Kind of screwed that up, didn't I? Yep. Yeah, it was 5,000. I'm not gonna worry about it. I don't like that, but oh well. I should have marked the wheel, but I didn't do it. My fault. You guys preoccupied with other issues. Okay, the plate's only, I only moved 1/10 on the machine up there from moving back and forth. So I can live with that. Okay, now we gotta see how centered we are right now here. So now I gotta center this thing up. I'm gonna center off my borehole. Sure everything's tight. Make it pretty even. Way off this way. And you just kind of bump it until you get it where you want it to be. Let's see, I gotta get get these holes centered up better. These aren't going in this time now because I don't know where it goes, but we're going to put them in a little bit. All right. Okay, we go a lot this way right now. So we're basically going to bang the wheel, the plate. I'm going to go ahead and rotate the plate here so we're on center. Okay, we bottomed out. We need to go this way quite a bit. Go this way because we're not hitting the dial. Okay, we're on the dial now. We're at 0. Re-zero it. Yeah, I think I went the wrong way. That happens. There we go, we're on the dial now. It's going to be about 12 on this dial, is about where we need to be centered at. So I'm just going to basically be bumping it away until we get this thing to 0 out. Let's see this way here. Looks like about 9 might be the number. We're 10 on that side. Like 9.5. Once you know what number to beat to, it goes quicker. It's 10 on that side. 10. Yep. The indicator recenters to half it out above. like 9.5 is going to be our number. Okay, looks pretty good. Pretty even. Now each line on this indicator is 1/1000, so pretty close. Okay, so we got everything tightened. We got that all in there. Now we got to tighten this plate down. So I guess I could pull these down over here with the holding power. Get this out of here. More than likely this is going to move on us. What are we going to do to hold that in? Okay, here's some shorter studs here. I'll put these in here. That'll work. Okay, I'm going to put washers and nuts under here. So I can pull this down. You need to lock the plate down onto the table, the rotary table, so it won't move. Can't get in or turn anything. There you go. Can't do one way, do another way. Okay. Okay, squeeze past here. Need access to the other side. Where's it at? So everything on this job takes a long time to do. Milling's real simple. The more accuracy you want, the longer it takes. You know, if you get to bring tools with you, it takes twice as long. This time I can take this side though. And there it goes. Okay, we got all 4 bolts in now. So now we get to throw the indicator back in there, just took out for no reason. And see if it moved on this end. Alright. So go ahead and check the indicator center line again. See if it moved any. We're still at 0 up here on the digital readout. Okay, so moved at 1,000s. It doesn't surprise me any. I definitely a spot I was hitting on that race. So I'm going to change the location to a different area. Check it again. It looks like we have moved it just a little bit. So we're 10 on this side. A couple tenths up that way, a couple tenths low that way. So we need to go this way a little bit. So we got to loosen these up. Every time I bang it, it moves a little bit. Okay, so I'm going to just tap this a little bit. We're going this way. That should be it. Excuse me. Alright, let's see what we got this time. Looks like we're holding 10 all the way around this time. Okay, that's looking pretty good. A little more torque on it. Alright, put it torqued. Double check our number again. Appears to be good. Alright, so we got that in there, not a problem. Pull this back out. Try our center bolt. Not sure how that's going to fly. Oh, dropped in a hole. Okay, that's tight. So they got 5 plates holding the plate in now. Get our indicator back up in here, double check. Actually, it's more like a triple check at this point. 0 it. Looks like we're moving slightly for some reason. For For some reason it's moved a couple tenths again, I don't know why. Shouldn't have moved at all, obviously. Okay, now I'm going to go ahead and crank this wheel and see what happens. By rotation, see if everything stays square like it's supposed to. Okay, where we in our, I can't see my location. Where's the valve stem? So our hole's over here, so if I know it goes back, the valve stem hole's right here. So if I crank all the way around to that again, we know we're square again. Alright, let's see if we get a consistent number this time. We were out 4th out last time. Look how it's moving again. It's 2. It's 2.5. 1.5. Look how quickly it brought back to 0. We started at 10. It was a big drop all of a sudden. I'll go -0.5. Oh, a little bit of a bump in there. Where's our hole at? Oh, we're back to our hole over there. We've gone all the way back around again. Okay. So it looks like we get about 2 instead of 4 or 5 out we were the first time. So we're 2. And we're -1 on one spot. And then it goes, boop, goes right back. Pops real back real quick. So there's definitely something wrong inside the race in there. I can feel a little nick in there. It's probably what I'm hitting on. Alright. I'd like it to be within 1, but anyway, we're about 3 total indicator reading. That's TIR. But pretty much about 2, almost all of it is where the maximum number was. Alright, we're going to live with that. I'm going to go ahead and get the center hole cut so I can get the darn race to go in here. And I'll cut the OD to get the sprocket to go on it, or the disc. Which side are we on? I think we're on the disc side. Valve stem hole is usually disc. Let's see how far down this thing goes. Oh, hurts my back. Back don't like the job before. See, I got a column spacer and a 6-inch column spacer. Actually, it's about a 4-inch column spacer. That gives me 4 more inches right here. Give me room to put stuff in here. When you start stacking stuff up on this universal jigging, it soaks up a lot of height real quick. That's why you need an extra big mill to do that. You do that by making it bigger, taller. Alright, put this in there. Looks like we got plenty of room. Put that in. Oh. All the way up to do this. Yeah, almost like I'm tired. Okay. All right. Cutter in here. Okay. Crank it back up a little bit. That's good enough right to there. Okay, so now I get the boring bar in here. So I'm going to go ahead and set the diameter here. We want to make sure that we're not hitting the actual bearing race, but we got to cut out the chrome part. That's going to be the fun part. So the first thing I do is crank this thing out to get out close to where we need to be. So you spend hours and hours getting stuff set up, making special tooling, and you spend 30 seconds doing the cut. It's one of them deals. Okay, I'm going to make it stop right there. Click on the power key, put the popper in there. Okay, it should stop in the right spot now. Okay, we should be close to what we need. Ah, come on. There it is. Okay. So I'm going to take a cut. So we got everything set up here. Got our depth stop set right here. So I'll go ahead and just put the power feed to it, let it power on down. Got to turn the RPM down a little bit. We're way the hell up in speed right now. Okay. Turn it down a little bit. Chrome, 840. Yeah. We're now feeding. See what happens. That didn't sound very good. Sounds like I just killed my bits, what it sounds like. Yeah, didn't help it any. Chrome is hard, did I mention that? Really hard. Okay. Now we got that cut. Now I need to get a bearing race and measure the amount of cut we got to do. Let's go get a bearing race. I didn't bring one over here. Okay, so we just squirt it on the floor. Oh, nice day. No wonder I'm getting tired. It's 10 o'clock. Sun's not up. There's a bearing race right there. Need one of these. Let me just see what we need. Need a caliper too. Yeah, it'll work. Could get all the good tools. Okay. I get some measurements. Figure out what we got. Basically, if it goes inside the hole, we know we're good. But we also have to cut down the hole without making metal out. So, right now it does not go in there. So we haven't cut too much yet. Okay, so we measure this. 779. This caliper's got about 3 thou wear on the tips, so they're going to be off by 3 the number. Let's see what we got. We got 740. So we got 740, and we need how much? 780? Ooh. We're not off by that much. Ain't no way. No. 776, not 740. Dumbass. We got about 3-4 thou. But this is 3 thou, so we actually got about 6 to 7 to cut in a real world number. And we're going way too fast for chrome. So I need to get this thing slowed way the hell down so it'll cut the chrome without destroying my cutter. Which I might have already done. Probably did. Let's see, we're at 840. It goes that slow. There's a few more thou, about 5 or 6 more thou there. See what happens. Okay, did it actually take anything out, or is it just making noise? It actually did take some metal out. Okay, we're at 7.8. We need 81, 80. We're at 82 over there. 781. 781, So theoretically that should go in right now. That 1 thou clearance. But being real world, it don't go in. Okay, so we're going to cut a little bit more off of that. We're cutting above the snap ring so the diameter can be loose. Another 3 thou more, 2.5 to 3. Still is not going to go in. Said chrome does not like to cut. 780. Hasn't moved any. Chrome over there. Nope. Okay, so this does not want to cut. So we need to find out what's going on here. Cut a little more. If this doesn't do it, we'll have to take it back apart and see what's going on. Cutter's dulled, blade's gone, something. I'll just chip all the chrome right off. We can take care of the problem. Oh, it actually did cut something that time. We're 84, 85. It should go in. Ooh, it's right there. It's trying to go. Trying to go. I mean, it is going. Yep. There. Jammed in there now. That's right there now. Press fit now. Okay. Cut that one more time. Change the cutter, or just cut more. See, now the bearing wrench drops in there now because we got a lot of spring load on there. The cutter's got an extra 6 thou worth of load on that cutter trying to make it cut through that chrome. Okay, so we're going through the chrome and into the snap ring, so now we're into the hole for the press fit, which does not have chrome on it. And it's feeling even now too, like it's actually at the right size. Okay, so now that is going, oh, there it goes. It just dropped right in. Now it's going in further it's supposed to go, which is not good. That means the chroming process has made the hole bigger than it's supposed to be. See how far the race is? It just kind of fill in there. So it's basically got like 1/2 thou clearance to 1 thou. There, see how it came out? So you can see I cut the chrome a little bit. It's really hard to see. I only cut from the snap ring up. But the bearing race is going all the way down to here. So when I put these in there, I'm going to put them with sleeve retainer Loctite. This has no chrome in the race down here, so I can push it in all the way and not worry about it. The bottom of the hole is a little bit bad down here at the very bottom though. Not very even, but the race will hit it and mush it out of the way or flatten it, whatever it needs to do. I don't want to go in there cutting on it. So. Alright, so we got the ID fixed. Now we're going to do the OD. And I'm going to cut it down until the this goes on there. Our rotor. That's not the one we're using, but we'll see. You can see how it's got some chrome right there. No chrome, chrome. So we'll cut that down. We're gonna go down until we hit this. We're gonna have to come back and we're gonna have to cut this away here, all this chrome. Preferably, hopefully not flake it off the edge. So we'll see. Ought to be interesting to somebody. Okay, so now we go ahead and take this out. That's a neutral. Okay, we'll take it out, look at our cutting bit here. See if there's any edge left on that. Appears to have weathered the buse halfway decent. It didn't help it any, but it's still sharp enough to cut. Okay, I'm going to flip it around 180, come in from the other side. Of course, now we're too far up to do that. I'll have to drop it down a little bit more. There we go. Appears I went in too far. Move it out a little bit. There we go. So now we're putting the bit in backwards. Okay. Now this one is going to fling further away from the cutter, so we can go until we drag and turn the machine on to fling out another hour or two. It won't cause a problem. It'll be above our chrome line though. There, we're hitting right there. Turn it on, see if that was enough to make clearance. Doesn't appear to. It's on the back side still. Alright, didn't change it much. Okay, we're at 41. So we back it up. Come back to 45 or so, let's call it. Okay, we're clearing the whole thing, but we hit chrome. Okay. So I'm going to bring it back a little bit more. It's 43. We go down until we stop. Okay, we should stop before we hit, but just to make sure, I'll back it up 20 thou on this side. Yeah, there's 30. It sticks up quite a bit. We'll give it a little extra. There's 50 thou. 60 thou back. We'll make sure I don't bottom into the chrome. Okay, turn that on. Go ahead and get this cut. Right down to there. Here's the action. We're going to go down now. See what happens here. That's all the chrome hitting. hit at the end there. Okay. So that was a pretty heavy chrome cut there, you can hear it. So we did was we cut the lip off up here, right through here where the chrome was. And then we're also cutting down here where the lip is right here, cutting that chrome away, and then we bottomed out against it. We're still not down to the heights of the actual aluminum, but we hit the chrome pretty hard. You can see how we're cutting over here on this red stuff over here, right there. Not too close. There's a lot of chrome over here, see? That's what I bottomed out against. Okay, so you can see how we're just starting to hit a little bit right in here. So where's my brake rotor at? Let's take our rotor here. See what we got here. Doesn't quite go on, see? It's trying to. Not quite. Okay, so we can go ahead and adjust our cutter here. Originally we're about 41 is where we're supposed to be, but it's 42. Looks like we're going to have to go lower than that. So I just cut to 40 even, so that's 3 thou more I just cut. So I'm going to go ahead and crank this down here until we get close, right there. Turn this thing on, and then we flip on to the feed mechanism here. Turn the feed on. Cutting on the outside right there. So we're cutting on the back side a little bit too. We're not cutting on this side here. We're going to bottom out here at the very bottom of this cut. Right there. Alright. So you can see how it's hitting a little bit here, about halfway down it quits hitting, so you get shiny, it's dark. The dark means we didn't hit, shiny means we were trimming across it, cutting a little bit. So you can see how it's cut right here, cut that little tit right there, and then nothing. So that's how close we are. Okay, let's see if this will go on there now. This probably won't go on. Oh, it does go on, okay. So we get way down in here, it's loose. Up here we got a little bit of clearance too. Alright, so that goes on. You wouldn't think 3 thou would make that big of a difference, but obviously it did. Okay, so now we got the ID fixed and the OD fixed. Now we need to work on the surface. Now this surface has to be clean, otherwise the rotor will wobble like that as the wheel turns. Plus it won't tighten up very well because you got all these high spots sticking up. It'll loosen up on you and come loose. Which would be bad also. More problems. Okay, I don't really care about the outside surface here, it doesn't matter. That's all clearance. Okay, so for cutting this, I need a different type cutter. This here cutter is not going to hold up. It has to be carbide because chrome is so hard. So we're going to use this one here. This has 3 bits on it. And I'm going to have to change out my big radius ones to something that's a little bit sharper, which means a new bit to destroy. And this can cut right up against the edge here, or really close to the edge anyway. So this will cut the material down. As I crank this wheel, it'll cut in a circle. And this will just, the milling machine will just turn it in a round circle this way. I have to crank the rotary table around to cut the OD of it. We're going to have a certain amount of offset this way, which we'll see up here on the digital readout. Okay, I got to swap out this cutter. So we'll go ahead and do that. And then we'll get to see how bad this wheel really is going to be. I'm sure it's pretty bad. It looks bad already. Okay. Cutter bit's getting less, it's getting more pissed off at me, but it's still there. It's definitely dull, but resharpening would not hurt. Okay, take this out. Just want to use a collet to hold it. Before I do that, I need to find me some more bits. So let me go ahead and find some more cutting bits and I'll be back. That'll take a few minutes.